So today's lesson is on Newton's law of cooling. We're going to use this information in order to be able to do tomorrow's activity. So take a moment, write down these notes on Newton's law of cooling. For those of you who are absent today, you can find your graded quizzes in the bin over by the pencil sharpener tomorrow.
Oh, we get our quiz back.
Which one?
The ones you took Tuesday?
Yeah, I don't remember taking them. Are the grades already in the campus?
Not yet. They will be third period.
I'm nervous about this.
Yeah. I'll enter grades third period, and then I'll finalize my first progress report grades.
Oh, this is so nerve-wracking.
Are they already online?
No, they'll be online third period.
So, there comes the subject.
Yeah, that's when you start getting the problem.
I'm just like, what?
That's where you start
Okay, so the formula for Newton's law of cooling is temperature with respect to time
I don't think we did that yet.
is equal to the temperature of the environment plus T naught. T naught represents the initial temperature minus the temperature in the environment times E raised to the negative K, and K is a constant. We're usually going to have to solve for that constant. Now, yesterday I gave you the constant, didn't I? And most of the problems we did. Today we're going to solve for it, and the lowercase t represents time.
I remember doing like those tasks in middle school all the time. Those were so awful. They'd grade you, and then they'd be nothing like what you learned in class.
Oh, yours tomorrow will be over this. It'll be an application of Newton's law of cooling.
Oh, you just took in 6. I get to check out of school, man. Oh, wow, cool, man. I'm getting cool.
I didn't say that.
You guys.
I got it. All right, so here's our example.
Well, can you just the test?
Huh?
Really fast. I said we usually, and then what's the last little part?
We usually have to solve for K. All right, here's our scenario.
No.
This is very crucial. It's about a hard-boiled egg. We have a hard-boiled egg that is at a temperature of 96 degrees Celsius. So obviously, we just boiled this egg. And is placed in 16 degrees Celsius water to cool. 4 minutes later, the egg is 45 degrees Celsius. When will the egg be 20 degrees Celsius? So go ahead and write down that scenario so you'll know what you had to tomorrow. You'll have something to look back at. And then we will set it up and solve it together, nice and slowly, and you can ask any questions you might have.
I fell when I was skating because I didn't know there was a brake on that. Because when on hockey skates there's no brake, and then on regular skates there are. And I got caught, and I didn't know it was there, and then I fell. Yeah. It just looks bad, but it's not that bad. It just hurts when you complaining about how badly it hurts.
My son has a big old
It hurts when it's on.
bruiser on his hip.
I have it on my whole leg.
Is that it? He covered for his buddy that pushed him down. He told the teacher that it wasn't really a push. Oh, it starts young.
Oh well, I actually did this to myself because I was being stupid.
Stitches get stitches.
Well, my son, they were playing. They're not allowed to play tackle football. And he was like, he just touched me. I'm like, oh, no, he didn't.
Why are they not allowed to play tackle football?
Because kids could get hurt like my son did.
That ruins all of
That's
it.
the point.
I know. They just can't play tackle during recess. They can play tackle in our backyard. All right,
Yeah, that's
so let's look at our scenario and figure what's going on here. Let's see what we have. What is 96 degrees right there? What is that? The initial temperature. So we know T naught is 96 degrees Celsius. Okay, what is this 16 degrees here?
Temp.
It is a temp.
Yeah.
The temperature of the environment. The temperature of the environment, which is the water. When we place the egg into the water, that is the egg's environment.
Water.
What would the temperature of the environment of this room be?
72.
Yeah, about the air temperature. Probably around 72. 68 to 72. Oh, that's not mine. I used to have a temperature. Oh, there it is. 70.3 is the current temperature of the room. Pretty good, guys. Okay. What else do we have? We have this 4 minutes. So we have some kind of time, don't we? We have a time of 4 minutes. But at that time of 4 minutes, we actually have a temperature. So we have a temperature 4 minutes later is 45 degrees Celsius.
Why do you capitalize the T?
Big T in my problem represents temperature, and lowercase t represents time. So this is the temperature with respect to time. So the temperature 4 minutes later is 45 degrees. All right, so let's start plugging in.
So what does the star stand for?
The star,
Oh,
that is a cursive T. It's a beautiful cursive T.
Oh, so that's a T.
Oh.
That's a T, as in time.
And the first one with the star on the other side of the equal
Yeah.
sign.
That's a T. It's a cursive T. Y'all don't write in cursive enough.
We don't like cursive. Remember that?
It's so much easier.
I know. That was embarrassing on the PSAT when half the people couldn't on the cursive. It was the statement. It was the statement. How do you make a cursive F?
I actually know how to write
Well,
that.
you know how to write your name in cursive, and that's about it. Why
That
do you
was
want
the
us to write
hardest
cursive
part of the
anyway?
whole PSAT.
Because
It'd be nearly illegible.
That's
Because
true.
it's more natural.
All right.
That's how we're supposed to write.
it is. Well, probably the people who write the SAT are quite versed in writing cursive, so they don't realize it's such a stumbling block for you. All right, temperature of the environment. Let's fill it in. 16s. Initial temperature. Let's fill it in. 96. We don't know K. But we do have a time. We have a time of 4 minutes, so we can plug in 4 for time. And 4 minutes later, the temperature is 45 degrees. So this function here would have to be equal to 45, 4 minutes later. Okay, we're going to stop right there and see if anybody has questions about how we figured out where stuff goes.
Wow, that was easy. Yeah.
All right, now we're going to solve this. I'd like you to do that. Please solve for K. Ooh, K is an exponent. Got to take a log. All right, we never round until the very end. And solving for K is not the end. It's kind of the beginning. So you're going to leave K in terms of natural log. Don't round. Gotta leave it just like this.
Oh, really?
Okay, when you're ready, look up, see how you did. Okay, the reason we're not going to round is if we round a little here, and then we round a little bit in a little while, and then we round one more time, by the time we get to the answer, we have compounding errors, don't we? We have a rounding error that could occur here, and then again, and then again. So it's best just to leave it exact until you get to your answer, and then I'll allow you to round the answer. On the last quiz, some of you rounded really early, and your answers were off by like 100. So you have to be careful where you round.
And also,
100. Yep.
we forgot.
The one that was 15,000 something, you were about 100 off. So when you round early, errors can happen, and we're not going to round anymore. It was quite a few students, so I know I didn't do a good job making a point of that, but I am making my point now. From now on, we do not round until the very end.
And also, we read our answers to the thousands instead of the hundreds.
Yes, if that's what the directions say, that would be a good idea.
Yeah, and
Well, bottom line, read the directions.
Yeah.
So only if the directions say to round.
I like how
Correct.
oh, see, I was like, oh yeah, round to the hundreds.
Okay, did you get this value for K?
Yes.
All right, so let's go back to our formula. You do not have to write this step. I'm just going to write it again. Okay? So, this was our formula. It's plus and then minus. Oh, and before anybody panics, if I were to give you this on a quiz, I would also give you the setup right here. Okay? So,
So we don't have to memorize.
yeah, you do not have to memorize Newton's law of cooling.
Not just like physics next year. You have to memorize it.
You don't
Okay. So, I know. That would be so simple for y'all, wouldn't it?
What?
Okay, so now I'm plugging in what I know. I know the 16, I know the 96. So really, instead of writing 96 minus 60 right here, what could I just write? 80. Okay, thank you. So that simplifies it a little bit. Now, I just solved for K, and I got negative ln of 29 divided by 80, all divided by 4. Now, what happens when this negative and that negative get together? It makes positive. So, I just wanted you to make sure you knew why that negative went away. Okay, now we have a nice, accurate formula. And we can answer the problem. What did the problem ask us? When will the egg be 20 degrees Celsius? So where do we plug in that 20? On the other side. So this becomes 20. And then we solve it. Okay, I'm going to give you the opportunity. Then I'll show you what I have. This time I want the actual. At the very end, you can round.
What place would you like this?
I have 2 decimal places in my answer. down here in the denominator. So what I did was, to solve this, I said ln of e is just 1. Bye-bye. Multiply both sides by 4 to get it out of the bottom, and then divide by.
I think it's way easier to leave it in decimal form the whole time. Okay.
As long as you have the entire decimal,
Yeah.
but it doesn't end.
I mean, it's about like, that one was only like 8, and that was 9 digits.
But on your test, some of you have on your last quiz, some of you have the correct answer, and those that rounded have an answer that's 100
Well, I guess.
100 years later.
How many
100 years is kind of a big deal
How many
sometimes.
points off is if you didn't round to the thousands, you rounded to the hundredths, like on all of them?
Wait, how did you get 11 minutes?
81 seconds.
How did I get 11 minutes, 49 seconds? I took the .81. I left this part of my calculator. I just subtracted 11 and left that in there. And multiplied it times 60. Because there are 60 seconds in a minute.
I did.
And turned it into seconds. That's what I did. I'd accept the 11.81 minutes, though. That's fine. All right, how do we do? Are we okay solving them? Do you see the process? Okay. Let me go ahead and end the video then. We're going to just do 2 through 5 on tonight's worksheet, though. 2 through 5.